Okay, guys, I'm going to go ahead and start recording today. And if we take a look at this, you may not need to show any of this work to get this problem right. But do show me what you're doing. All right? If we were to do this using the tools of dimensional analysis, which we learned, we're going to try to take yards all the way down to millimeters. So you were given this conversion between centimeters and inches. So I need to get yards to inches. So I know that there are 3 feet in 1 yard. And I know there are 12 inches in 1 foot. So now if I look at this cancels with this cancels with this, now I'm down to inches. Well, now I know the conversion for inches, and I want inches to go away, so it would go in the denominator. 1 inch is equivalent to 2.54 centimeters. And hopefully you guys all know that there are 10 millimeters in 1 centimeter. We like the metric, well, I like the metric system better because it's based on tens. And so we know that there are 10 millimeters. All right, so when we multiply all this out, we get 49,377.6 is approximately how many millimeters there are in 54 yards.
I don't, wait, you just multiply those numbers?
You multiply 54 times 3 times 12 times 2.54 times 10, and then you divide by 1. So you don't really divide by 2.
So do you add the bottom ones and divide by?
You would multiply all the bottom numbers and divide by that if there were numbers in the denominator. Yes?
It's not an equal sign, but
The squigglies? Approximately equal to. Approximately equal to. Because I rounded. Whenever you round, it's no longer exact, and you really shouldn't use an equal sign.
But I just plugged that in and I got that exact answer. Like those numbers.
Oh, it is exact?
Yeah.
Oh, I know why I used approximate. Because 2.54 is an approximation. This is actually approximate here.
Oh.
Yeah. Okay. Homework. Good question, Rose. Thank you.
So does that put into decimal? Oh, you have the little decimal.
I do, but this one I would leave like this because when you do write it as a decimal, it's a non-terminating, isn't it? We had to round. And when you convert a fraction to a decimal and it's non-terminating, then you've given an approximate answer versus an exact answer. Now sometimes we do need an approximate. When we're working with word problems and, 3.26 toes wouldn't make sense. So we would have to round one way or the other. Okay, let me scroll down so you can see 3 and 4 now. Okay, last period somebody asked, can I multiply by 4 and divide by -3? Yes, but that's 2 steps, and this is 1 step. So we would like to be as efficient as we could. So instead of multiplying by the 4 and dividing by the -3, when you have a fraction, you can just multiply by the reciprocal. It's more efficient. Okay, any questions about 1, 2, 3, or 4?
For number 3, I just used 0.75 because I already knew the thing was better.
That would be fine unless it was a no calculator. And then you wouldn't want to switch that over because you just made the problem harder for yourself. This, and I even mentioned this last year, this could be 100% a no calculator question.
On your quizzes and tests, do you let you get your numbers?
No. most of our quizzes and tests will either be no calculator or part calculator. Very few of them will be entirely calculator. And when I say show work for credit on a test or quiz, you must show work to receive credit. Because Miss Willoughby knows what the technology will do. I like to play with it too. And so, it'll do a lot. Too much sometimes. Okay, number 5. How are we doing clearing fractions? Are they getting better? No? All right, let's look at our denominators. What's the common denominator for 4 and 5? 20. So every single term must be multiplied by 20. Each term, whether it had a fraction or not, has to be multiplied times 20. So negative 1 times 20 is 20. 4 goes into 25 times, so this becomes 5x. 3 times 20 is 60. 5 goes into 24 times, which gives us 8x. And then we have a very simple equation to solve. I chose to subtract 60 from both sides and then subtract 5x. So I get negative 80 equals 3x, and so negative 80 thirds equals x. A simplified improper fraction is completely acceptable.
Wait, how did you get from 2x over 5? Like, how did you get from that?
Okay, so I said this was, let me get rid of all the blues so you can start it right. We chose to multiply everything by 20. Does that make sense? Okay, so right here we said 5 goes into 20 4 times. And 4 times 2x is 8x. Yes, sir.
So whenever there's like fractions that include a variable, you can do that.
Even if they didn't, you can always clear fractions. Okay, how many of you got the red circled answer for number 6?
Well, I got it, but I got like 0 point.
Okay. How many of you got the blue circled answer for number 6?
I got negative 3.
Who's right?
Oh, sorry, the blue.
They're both blue one.
They're both right.
It's the same
It's the same thing. It is the same thing. Okay, so if you got a decimal, then something went awry somewhere. Did you distribute the negative and you have a negative 5x and a plus 6?
Yes.
Check that. Okay, so when you added 4 and 6, you got 10?
Yes.
Okay, so you have 10 minus 5x is less than or equal to 18 minus 3x?
I don't know.
Okay, so then what did you choose to do? Did you move the 10, the negative 5x, the 18, or the negative 3x? Because we have 4 choices.
I messed up
Put down the wrong
distributing.
number.
Okay, you messed up distributing, you just copied your number wrong. Alright. Does this make sense? Excellent. Okay, so number 7 was not complicated at all. It was just long. Nothing about it was hard. It was just long. Now, you won't believe how many times I give this and people tell me the answer is 13 over negative 3.
I only got negative.
I got
negative
9.3.
Well, I got negative.
Okay, check your work. I have my work step by step. It should match exactly up until this step. After that, you may have picked differently. But you should check the first 2 steps and see if you can find your error.
I got that one.
Good.
I had an error with distributing.
Can you explain trade?
Sure.
Have you got
Are we good with number 7, Marissa? No. So you were good up to here?
I have 7x plus 11 equals 6x plus 8.
Okay, this should be a negative 6 because this was a negative 12. So 6x minus 12x is negative 6x. There you go. All right, so let's talk about number 8. On number 8, we've got 5, 3, 2, 3. Common denominator for 5, 3, and 2 would be 30. So every single term in this equation gets multiplied times 30. So 5 goes into 30 and gives us the 6. 3 goes into 30, and that's where we have 10 times. 2 goes into 30, and we get 15 times the 1. 3 goes into 30, and we have 10 times the 2. So this gives us 12x minus 10 equals 15 plus 20x. And then at this point, you have choices about what to do to finish. Now this one, it's just fine to switch this to a decimal because this is a terminating decimal. That is an exact answer. So if your decimal terminates, you're welcome to change it into a decimal.
Sorry, I was reading the answer to number 8 and number 6, so I didn't get it. That's the one.
What now? Were you saying you needed to see a different one?
No, like on number 6, when I said I got 3.125, I was
You were reading the answer for number 8. Okay, I'm following you now. I'm with you. Okay, any other questions about number 8? Okay. Here is number 9, the word problem, written as an equation, and the solution. And number 10's word problem, I said let J represent Jake, so Anna is 30 more than Jake, and Kyle is 5 more than Anna. So it would be 5 times this 30 plus Jake. So this gives me Jake, Anna, and Kyle's money together equals the 271. And we solve, and Jake had $13. Are we good with number 9? Did you catch the 6 less than, and you knew you needed to subtract 6 from the 2x or 2n or whatever you... Good. Good. Okay. This one, I changed yours after I wrote the answer key, so I had to do some whiting out here. On this one, they did not distribute the negative correctly. Did you catch that? Yes. But they did combine like terms right. They did everything else right. And if they had worked the problem correctly, they should have gotten 5.25. My movie board battery will not make it through the day anymore. That's a sad, sad thing. Okay, let's see. Okay, any questions on 12 or 13? So those are our two different cases where variables cancel. We either get a true statement, and I think we said in class yesterday we were going to say all real numbers.
I put infinitely many.
Okay. And I even wrote that too. Generally, and I shouldn't have written infinite solutions. But I guess if you thought of there's no solutions in infinitely many, it'll work. Yes, sir.
If I'm guessing, if there's somebody write infinite solutions,
It's fine.
all real numbers,
Yeah.
like, that's what I'm.
Yep. You'll be good. Okay. I want to try 1 or 2 more of these today. Okay. You talk me through this one. Don't write this one, just watch. What do we do first? Common denominator. What is the common denominator? 6. So every term gets multiplied by 6.
Can't you like divide it or whatever, and like make those two be times 3 and now on times 2.
That's what we're doing now.
Okay.
Very good. That's right, Annabelle. We're going to say 2 goes into 6 3 times. And 2 goes into 6 3 times. And 3 goes into 6 2 times. So that is our next step. Divide the denominator into what we're multiplying by. And so we get 3x plus 15 plus 3x minus 3 equals 2x minus 2. So that's 6x plus 12 equals 2x minus 2. Subtract the 2x. And at this point, you could pick. You don't have to do it this way. I have 4x plus 12 equals negative 2. Subtract the 12. I get 4x equals negative 14. Divide by the 4. And this simplifies to x equals negative 7 halves. Got it? Okay, the next one looks a little different. We have this 2/3 out here and it's multiplied times this. So it might be best if we go ahead and distribute that. Now when I do 2/3 times 1/4, that gives me 2 over 12. What does that reduce to? 1/6. Now, I could have just said 2 goes into 2 once, 2 goes into 4 twice. That's 1 times 1, 1, 3 times 2, 6. Okay, at this point, I want you to try and solve the rest of that problem. You try. Not sure what to do. Stop me. Some of you noticed that we had a 2/3 W right here and a 2/3 W right here. And if I just subtracted it from both sides, the variables went away. Others of you saw fractions and went, ooh, let me clear them. Okay? So, if you cleared the fractions, then you multiplied everything by 12. And so we'd say 3 goes into 12 4 times, so this is 8W. And 4 goes into 12 3 times, so that's minus 3. And 3 goes into 12 4 times, so that's 8W. And then this gives me 2. And so you saw here when I subtract 8W. So either place you saw it, you saw where we had one number set equal to another number that it is not equal to. So you either had in this step right here, negative 1/4 equals negative 1/6, which is not true. Or you cleared the denominators and you were left with negative 3 equals negative 2, which is not true. So what does that tell us? There is no solution. Okay. Are we good? All look at something a little different now. Last night we started doing word problems, and I want to talk to you about what consecutive integers means. What does consecutive mean? Yes, Rose?
Like one after the other, like 1, 2, 3, or 4, 5, 6.
Exactly, one after the other, like 1, 2, 3, 4, 5, 6. Those are consecutive integers. So when I have a problem that talks about consecutive integers, I always let x represent the first integer. So if I was doing consecutive integers, then to get to the very next one, wouldn't I just add 1? So x plus 1 would represent my second integer, wouldn't it? And x plus 2 would get me to the next one, wouldn't it? That would be my third integer. What would the fourth one be? X plus 3. Okay? Now, what if it had said 3 consecutive even integers? Instead of adding 1, what would I add? 2. And then add 4. What if it had said consecutive odd?
0.
It's still 2 and 4. Just the first one would have been an odd number to start with. But you still add 2 and then 4. Okay, so now I've labeled my first 3 consecutive integers. X, x plus 1, and x plus 2. Then it gives me something weird here. A lot of times it'll say the sum of 3 consecutive integers is, so we just go x plus 1 plus x plus 2 equals whatever it tells us. But this one doesn't. It says, find 3 consecutive integers such that the greatest integer, well, isn't this my greatest integer? X plus 2 is, what does is translate into in mathematics? Equals 2 less than. What does that tell me to do? Subtract 2 from something. What am I subtracting it from?
X.
3 times the least. How would I represent that?
3x.
3x. And so we would subtract the x and add the 2. And we would get, that's not a 2. So we'd get 4 equals 2x, and so 2 equals x. So 2 would be my first integer, so it would be 2, 3, 4.
Wow. Oh, okay.
Does that make sense?
Yes.
Great. Okay. The next thing is inequalities, which are no different than equalities. But let's take a look at this one. If I add y to both sides, what immediately happens? The variables cancel. Now, is that a true statement?
Yes.
Oh, yes.
Is 7 greater than 5?
Yes.
Yes. So this would be all real numbers. Or infinite million solutions. I'll take either. Okay? What if we got something that was not true? What would it be?
Like
No
4.
solution. So just like with equalities, with an inequality, when your variables cancel, if you have an answer that is true, it's all real numbers, and if you have something that's false, it's no solution. Okay, the last thing I want to go over, because I was checking your summer work, and I noticed that the compound inequality problem stumped a lot of you. And I'm not sure you've seen them before. But what can you do to find something that you've never seen before? You can ask, you could Google it. I learned how to tile my entire kitchen watching a video that I Googled. Yep. I learned how to get the CDs out of my, the DVD, out of my DVD player when my child stuck 3 in them and they were all stuck in the car.
How do you?
You stick an envelope in there, and you have to do it a certain way, and then you pull. And you have to push the button at the same time. Yeah. So, everything. You can Google just about anything. It's crazy. Okay. So,
Sideways in the car, goes going sideways.
alright. So, let me show you compound inequalities, and you'll go, oh, that was easy. Why didn't I do that? So the first thing we're going to do is look at how would we translate the words into the compound inequality. And compound just means we're going to have more than one inequality. All real numbers between -6 and +6. How could I represent that statement as a compound inequality? Well, X represents all the answers. So this means all the answers are between, what's the small end? -6. What's the large end?
+6.
Done.
That's it.
This is the compound inequality that represents that statement. -6 is less than or equal to X, which represents all the answers, is less than or equal to +6. Now, this is a compound inequality that's not solved. And to solve for B, we have 4B minus 3, and we want to solve for B. So we do it just like an inequality. We got to get rid of this 3, and we got to get rid of the 4. What do we do to get rid of the 3? Add 3. But since it's a compound inequality, whatever I do to the middle, I must do to both ends. Yes, to both sides. So I'd add 3 there and there. And so I'd get 8 is less than 4B is less than or equal to 12. And then what would I do? Divide by 4. Divide by 4. Divide by 4. So I would get 2 is less than or equal to B is less than or equal to 3. So any number between 2 and 3, when I plug it in, will give me a true statement. It will fall between 5 and 9. Now last period someone asked, what if this were negative? Well, that would be negative, which would tell me I'm dividing by a negative. And when I divide by a negative, what happens? It flips. Let's see if it still makes a true statement. Will this work? Yes. Because the alligator always eats the bigger number, doesn't it? Isn't -2 larger than -3? Yeah. We could write this as this. -3 is less than or equal to B is less than or equal to -2. So, compound inequalities work just like regular inequalities, but at whatever you're doing to solve has to happen on both ends of the inequality. All right. For your homework, you have these problems from the textbook, which you may have time to do in class. And then the back of the activity sheet I'm going to give you. Your activity sheet is a group activity. So you may work in groups of 2, 3, 4, 5 if we need to finish this activity. So this is the homework. If you're watching the video, we're ending it now, and we'll go over all this tomorrow.